All right, my people. Yes, I decided to record the rest of the computer science concepts. So sorry, I was having network issues. So that is what happened towards the end of the part one. Okay, was network issue. So I said instead of doing another live stream and running into those problems again, let me just record and I will post it as a part two. Okay, so if you have questions, please ask in the Slack. Okay, unfortunately, it's not live for me to answer as I am recording. Okay, all right. So we had stopped at the computer security part. I think that was where I started having my issues. So I'm going to repeat that part again and then I will continue. And I will try and finish. I will try not to rush, but just to get so that the video is not too long. Okay, all right. Thank you for bearing with me. Okay, so back to what we were discussing. I started this section by saying that hacking is unauthorized access. Okay, unauthorized access to any computer system. Okay, that's hacking. All right. Sometimes we think of hacking as one thief somewhere, in a hole somewhere with computers all around them. You know what we see in the movies. But hacking is actually I can hack my friend's phone. If I know enough about her, maybe I think, okay, she will use her birthday as her PIN number. I can hack her phone. Okay. So hacking actually is not as mysterious, as sometimes movies make it out to be. Okay, so this section here, they're talking about different types of hacking, so let's go through it. Brute force attack, okay, is all about just throwing so many different so many different credentials, okay, just different combinations, doing it very fast, just doing anything, 11111 22222, trying to use popular passwords. Sometimes when you have these data breaches and people's passwords are exposed, hackers will gather them, and put it into their database to now be using. Brute force is all about, I'm just going to keep attacking this logon page, as much as I can, right? That's brute force attack. Social engineering is a little more sophisticated. It's about appearing friendly and appearing legitimate so that people will willingly share stuff. Okay. So in this case, you're not like forcing your way. It's almost like you're using friendship or you're using familiarity to, you know, uh, make the person to trust you. And from that trust, you will now share what they hope is personal information, and they will now use it to access your system. Okay, that's social engineering. Security exploit is looking for a way to gain entry and from a port or an entry place that is not as protected. So let me give an example. Let's say you're trying to hack somebody's social media, okay? So you gather all the potential social media that they have: Facebook, Instagram, what is that one now? Facebook, Instagram, Snapchat, TikTok, so let's say you try to hack their Facebook. You see, oh, they have two-factor authentication, which is when you try to log in, you have to send a text. Hey, you're like, okay, that one is too strong. Maybe you now start trying all the other social media. You're hoping that one of those social media will have weak password. Okay, so that is security exploit. You are exploiting one social media, hoping to gain information that will now allow you to also access the other ones. Okay, so that's an example of security exploit. Trojan horse, this comes from Greek mythology. A Trojan horse is basically a software or a program that appears innocent, okay, and appears helpful. And the hope is that you will believe that is helpful and you will install it, but actually hidden within that program is a malicious software that has a negative purpose. Okay, so for example, the software may say, oh, this is a cutting edge email program. Okay, it does more than Gmail. And so you install it, but then hidden within it, let's say, is a program that record your keystrokes when you type, or it reads what is on your screen when you open another app, or you open a browser. It reads what is on the screen. So that malicious program is now gathering information, and trust me, there will be a way that it is sending that information back to the creator of that program, again, to gain information so they can hack your other systems. Okay, so that's a Trojan horse. A rootkit. Okay, so root access, like if you think of Windows, on Windows you have different user types. You have administrator, you have regular. Root access is the most powerful user type on any computer, any server, any computer, any phone, any iPad. Root access is the most powerful. With root access, you can do anything. So a rootkit is a program that seeks to gain root access. Okay? And the whole point of gaining root access, what? Is to gather now information that only root has access to, or to do other things using that root access power. Okay? So that's a rootkit. Now, distributed denial of service attack, okay, or a DDoS attack, okay? A DDoS simulates a large number of users, a large number of clients, like a server or a website, okay? It simulates a large number, okay? And what it does is it overwhelms the system with the purpose of shutting it down, okay, or bringing it down, okay? DDoS attacks are very popular against like mission critical systems. For example, here in America, Department of Defense, they have a lot of DDoS attacks. Why would somebody want to bring down server in Department of Defense? Because if you can bring down the server, it can leave an opening that hackers can now exploit, okay? So DDoS is not so much about gaining information or stealing information. DDoS is bringing a service down, bringing a server down, and that itself becomes a gateway for hackers to gain access, okay? Okay, now this section, cryptography, okay? I'm not going to go too deep into it. Like they said up here, they said cryptography is the study and application of secure communication. I know for our cloud engineering people, security for all of us in general, but particularly for cloud engineering, security is so important. Security is everywhere. Again, because of number of people, number of devices, security is one of the most important aspects of software development and really just tech in general, okay? That's why cybersecurity is such a booming field now, okay? Because of that security, okay? So cryptography has to do with secure communication. How can we communicate in a way that unauthorized people don't have access to our communications, okay? All right. So now this is just looking at two main different types of cryptography, okay? Where you have symmetric and you have asymmetric. So with symmetric, like they described here, there's a box. Alice and Bob have a box. If they want to communicate with each other, they use the box. They have two identical key for the lock of the box, okay? So what that means is each of them have a key. If Alice wants to send something to Bob, she puts it in the box, she locks it with her key, and then Bob will come to the box, open it with his key, which is the same as what Alice has, but he has one copy, she has one copy. Then he's able to open it and look, okay? Now, that's symmetric. Then now we have asymmetric, and asymmetric was developed because of the downside of symmetric, okay? So with asymmetric, like the example here, it said that with two people, symmetric is okay. You having, a copy of one key. But what if she now has multiple people? Like she now has Carl, okay? She cannot copy that key that she has with Bob and give Carl, because yes, it will work with her own box with Carl, but Carl would also have access to Bob and Alice box, okay? So that's not a solution. Now, Alice could decide, okay, let me have a separate key pair with Carl. So now Alice has two keys that she's holding, one for Bob box, one for Carl box. What now happens if there's 20 people that she wants to securely communicate with? You can see how that becomes very unmanageable, okay? So what asymmetric cryptography does is Alice will have one key, and it is known as a private key, okay? It's known as a private key, okay? So then she now has, over here they said padlock, but let me just say box. she will now have the multiple boxes that she has with her friends, as many, okay? Now, it says here, anybody can close the box, but only she can open them, okay? With that one key, okay? So, what now happens is, if she now wants to communicate securely with Carl using his box, okay, she will ask for Carl's, okay, I see why they say padlock, because the padlock is used to lock the box. Okay, so she will ask for Carl's padlock, which is known as a public key, okay? And then using her private key together with Carl's public key, she will now encrypt. That's where the encrypt comes from. She can now put her communication in the box, and because she's using her private key to encrypt, the lock, Carl now is the only one that can unlock it. Okay? So, asymmetric cryptography is a whole field in and of itself. So, I don't want you to get confused with it. I think this example they shared here is good. Just read it. The key thing to just note is that asymmetric cryptography allows you to have multiple channels of secure communication without maintaining a separate key for all of them. That's it. Once you get that, you're okay. Okay? Because with symmetric, you have to have a separate key with every channel of communication. Whereas with asymmetric, you can have one key and yet communicate with multiple channels securely. Okay? And that one key is known as a private key. That's really all you need to know. Okay? All right, let's continue. We have quite a lot to get to. Okay, so now we come to software development methodology. Okay, this is important. Okay, because the way that we have developed software, or the process by which we build software, has changed over the years. Okay, so the more conventional way, and some places still use this way, is called waterfall development. Okay, waterfall methodology, waterfall development. Okay, in waterfall methodology, from the beginning, you figure out everything that needs to be done. That is, from conception to deployment of the application, we need to figure out everything that needs to be done. Okay, and then you start step by step. So maybe the first step is, planning the application. You plan it from, you plan all the details. You plan it. It's like you don't have an application yet, but your dream is to have 1 million users. In Waterfall, you plan it as if it's going to be for 1 million users. That's Waterfall. So after you plan it, then you give it to the designers. They will design it, the user experience people, UI people. Then implementation, that is when, the engineers come and they engineer it. And then verification, which is also known as testing. You test it, and then deployment and maintenance. So the reason it's called Waterfall is because it's step by step, and really you don't go back up. Okay? So with the planning stage, you planned everything. You planned it to the end of the world. So according to Waterfall, there's no need to plan again because it has already been planned. So that's why it's called Waterfall. When a water falls over a cliff, water cannot go back up. So that's why it's called Waterfall. Okay? That has been conventional, but it has been replaced largely by Agile. Okay? Agile is about little, small, tiny tasks, small projects, breaking up the overall, goal, the overall purpose into little chunks, and building those chunks and shipping them, deploying them, and seeing how it does in the marketplace, and then taking that data back to the drawing board. How can we improve? Okay, this little part is working. How can we add? So that's why it's called Agile. The word Agile means flexible, able to change and switch quickly. When you say this dog is very agile, what that means is this dog, no matter the obstacle in front of it, it jumps over it, it goes under, it's able to find a way forward. That's why it's called Agile. Agile is like the opposite of Waterfall. Okay? In Agile, there's a concept called minimum viable product, or MVP. Okay? Your MVP. So even though your goal is for 100 million people to use your app, you start with 10 people. can we engineer an app that 10 people can use successfully? That's your MVP. Okay? You're not thinking about server space, you're not thinking about database. No, because you're only engineering it for 10 people. And then you allow those 10 people to use it. And then you get your feedback. You know when they say beta launch, beta testing. You get your feedback. And it's that feedback that you now use to now make it better. Then you can expand to 20 people, and you can expand to 50, and you expand to 100. That's Agile. Okay? Agile does not wait for everything to be perfect before it ships. In Agile, there's a saying, it says ship early, ship often. Ship early means don't wait for it to be perfect, ship it, let people start using it. Even if it breaks, the breaking will give us data. And ship often means because you're shipping early, you now ship multiple times, so you ship often, okay? So that's Agile, and it is more popular today. And there's different there's different subcategory under Agile, Scrum, Kanban, you can read them there, okay? But that is Agile in general. Okay, now, this part, I think is good. You can just read it. It's called Software Development in the Real World. You can just read it. I think it's just talking about, okay, how does it really work in the real world? Okay? How does it work in the real world? That is, you see like this drawing here, say what I thought. The marathon, look at the track, It's a white track. You just follow the track and you get to the end, the green flag. But it's saying that, software development in the real world is really an obstacle course. You accidentally took the wrong route. So you took, you made a wrong decision and you ran with it. And then you get to the end, you say, it didn't work. Then over here, your friend suddenly quits or your coworker quits and you were working on something together. Now they quit. Now it's only you. Then over here, you got injured. Over here, the finish line, this one happens all the time. Product has told you, okay, this is where we are going. And then you're now working, you're working on getting there. And then product will come and say, actually, we got some data. That's no longer where we are going. Now we are going here. It happens all the time. So I think this section is just showing you that, software development in the real world is not perfect. Okay? It's not perfect. It's a process that you make mistakes, other people will make mistakes, things will happen to change your direction, change your goal, change your objective. And the key thing is remaining flexible and not taking things personal. If you're someone that takes things personal a lot, you will not go far. Because so many things happen is not personal. It's just the way the process is going. So you have to adjust. Okay? All right. And then there's a funny comic down here. You can also read that. Okay. It looks like at the bottom here, they're just asking some questions. I don't think they are so important. I mean, some of them are like, for example, what is the difference between computer science and programming? What is programming? You can read it. This one is silly. Why shouldn't you interrupt a developer when they are in the zone? I don't know what is that. I mean, as a mother, there are so many times I'm coding and my daughter will come and jump in my lap. Will I say I will not look after my daughter because I'm in the zone? I think it's stupid, but some people maybe they think it's important. Okay, what is the difference between Java and JavaScript? They are two completely different languages. Okay, even though they have a part that is the same, Java, but completely different language. What's the difference between JavaScript and jQuery? jQuery is built on JavaScript. Okay, so jQuery is a language that abstracts a lot of JavaScript away. So instead of writing a whole lot of JavaScript, you just write one line of jQuery and it does the same thing. Okay, so jQuery is built on JavaScript. Okay, what is the difference between a framework and a library? A library is a framework, like for example, React. React is, a framework is like Angular. Angular is a framework. React has a framework now, but in the early days, React was more of a library. A library is like a collection of software development tools and like maybe APIs that you can use in your project. Whereas a framework is what you, that is, for example, Ruby Rails is a framework, not a library, okay? Ruby Rails, the Rails part, that is your actual application. The framework actually defines for you what your project will look like. Whereas a library, you just import it and use as you wish. So a framework is more prescriptive, okay? A framework controls more of your project than a library. A library is like a hammer that you say, okay, I want to use a hammer and nail this nail in, okay? Whereas a framework is like, okay, you want to build a chair. This is the blueprint for building a chair. That blueprint is now the framework for that chair you want to build. Whereas a library is like a hammer, a pliers, a saw, things you can use as you are building. I hope that makes sense. Okay. Some of these questions, like this one, I don't see whatever. What is object-oriented programming? Object-oriented programming is a way of is an approach in programming where you encapsulate certain properties so that you can use it as a whole instead of using each of the parts. I think the way they described it here, I think if you read it carefully, it makes sense. But let me see if I can give an example in a code. Okay. And I will try my best. I may make mistake, but let me try. Um, let's say we want to describe um, I wish I can do it in Ruby. I'm not very good in JavaScript. Let me do it in Ruby, if that's okay with you, because I'm a little stronger in Ruby. Okay, so I'm just going to create a repo. This is just like an online IDE that I can use to run Ruby. Okay, so let me just bear with me, because I'm doing it on the go. It's not something I planned before, so just bear with me. So let me say class animal, okay, and I say n, okay, then I say def initialize. I think that is it. That's been so long I've done something like this. Oh, let me how can I make it bigger? Sorry, let me increase the font size here so you can see. All right, okay. Okay, so class animal def initialize, and I'm going to say type, okay, and it's going to say okay, it's going to say puts. Let me not say animal. Let me say no. Okay, let me say animal. And it's going to say puts. I am a type. Okay. All right. And then let me say sound. Okay. No. Sound. Let me see. Okay, let me say sound, and the sound, let me say let me say speak, and let me say sound, okay, and it will put I'm just making things up here, so just bear with me. I'm trying to show an example of object-oriented programming, okay. Let me say let me say no let me say and let me say friend, let me say let me say friend. Friend, and then I'll say and please, you don't have to know this. I keep saying it, you are not here for coding. So let me say friend, and let me say animal. No, let me not say animal. Let me say other animal, okay? And then it will put I really like other animal, and I'm going to say pluralize. I think pluralize. I think that works for Ruby. Okay, and then the final method is enemy, and we're going to also say other animal, and is going to put I really hate. Okay. Okay. I hope this works, and I'll explain as I go along. Okay. So now, I want to. Okay. So outside of this class now, I'm going to let me just see if it works. I'm going to put animal new, and I'm going to say dog. I just want to see if it works. Okay, it's updating some configurations. Okay, and it's executing. Aha, okay, good. So let me explain what I have done. Okay, this is an object called animal. Okay, I created in Ruby, it's called a class. Okay, but I created an object called an animal, and this object has I can do different things with it. Okay, so I will do it, and then I will explain. Okay, please, I'm just trying to show you what is called object-oriented programming. Don't memorize any of this. I keep saying it because you're giving yourself extra work. They're not going to the exam is not going to test you on what I'm doing, but I want you to understand by seeing it in action. Okay, as opposed to somebody just telling you with mouth. Okay, please don't go and put load on your neck. Okay, so let me say Fido. Let me say Fido, which is a popular dog name. Let me say Fido is equal to animal new, and it's going to be a dog. Okay, all right. So I created Fido. Now if I say put Fido, okay, let me see what happens. Okay, so let me clear. I just need to see what happens first before I start to. Okay, so it's executing. Okay, so whenever this object is the animal object, okay, and instead of me, I don't know how to say it. Like instead of me, by saying Fido equals animal new, okay, I could have said instead, let me think. I could have said Fido equals I am a dog. Because you see, when we had it as an object where I'm creating the animal object, and then I put it, which means I display it on the console. Because it's an object, when I put it in the console, it showed me that I am a dog. Okay? And then it ended with, this is the object, this is the actual object in memory. Okay? But it showed I am a dog. Now, if I was not using an object, okay, I would have had to, instead of saying Fido equals the animal object, I would have just said Fido equals I am a dog. Then if I put that Fido, it will give me the same result. It will give me the same text. I am a dog. Okay. But now let's see the power of object. Okay. So let's remove this one. Okay. And go back to our object. Okay. So now I have this Fido. Now, if I put Fido, it will tell me I am a dog. Now, if I put Fido speak, and I give Fido what to say, woof, which is the sound a dog makes. Okay. So I have created an object, an animal object, and I am now using the different functions available to that object. Okay. So if I now run the console, okay, because, when I created the object, when you create it, initialize, it put, it displays this. So you see, it says, I am a dog. Then it said, I make the sound woof. If I didn't have the object of animal, I will have to code all of this myself. So like before, instead of this here, I will have to say Fido is equal to I am a dog. And then I will have to say, how do I do this now? I will have to, like in order to do the speak, I will have to say, maybe Fido speak is equal to I make the sound woof. You see, I will have to code every single, and wherever I'm using this Fido in the code, I will have to repeat this each time. Okay, but with the animal object, I can make any kind of animal using the same object, using the same class, using the same object. Okay, so in this case, sorry, let me just make this last example, then I'll stop. Okay, so for example, this is Fido, which is a dog. Okay, I can also say Puss. Okay, and Puss is a cat. Okay, so if I say Puss, okay, and I run that here, it will say I am a cat. I don't know why it's saying I'm a dog, or maybe it was old. Okay. Oh, I think it's just okay. Whenever it initializes, it will put this out. I don't actually have to, I can just say instead of put, let me change it. Let me say self type is equal to type. Okay, so let's see how that changes. Okay, so I have Fido and I have Puss. Okay, let me change it so that we don't keep getting that output. So if I put unknown type for animal, what's the problem? There's something I'm doing here. Self type is equal to self who am I is equal to type. Oh, okay. Oh, self, what is it? No, I'm forgetting how to do it. Forgive me. But I think you get the general idea. Object-oriented programming encapsulates different abilities inside an object so that when you create that object, you now have access to those functions, or you have access to those abilities without having to code it by yourself each time. Okay? Okay. Let's go back. I hope I've not confused you. I hope that didn't confuse you. Well, if it did, just ask me questions. Okay. But I wanted to give just a quick example. It's been a long time that I've written an object or a class from scratch. Okay. We've already talked about API. Okay. I think we've talked about API in the Slack. Okay. And then this is, difference between SQL and NoSQL. I don't really think this is so important for you to focus on, to be honest with. This is database, database programming. In general, I would just say, let me see if I can explain it to you. SQL, I think it's called structured query language. That is the meaning of SQL, is structured query language. SQL is a database setup that has to do with databases that relate with each other. So let me try and describe it. Okay, let me try. Okay, so in SQL, you have databases that have tables. Okay, so you have a whole database. Okay, that's the black. Now, let's say we have two tables. Okay, database contains table. Okay, so we have two tables. Okay, now in each table we have record. Okay, in each table we have record. So let's say this table is users. Okay, and this table here is orders. Okay. Now in the user table, let's just make it easy. Let's say we have two, what is it called? Two fields. Each table has field. So let's say in users table, we have two fields, and the fields are ID and name. Sorry, I'm writing with my, I have a pen here, only the pen is not charged. I'm writing with my finger, that's why it looks weird. Okay, so let's say now we have 3 records in this table. ID 1, 2, and 3. And let's say this name is Sam, and this name is John, and this name is Sue. Okay. Now, each of these users have placed an order. Let's say they've each placed one order. Okay. So now in the orders table, and sorry, I have to make it a little bigger because it's going to have a little bit more data. Okay, just bear with me. Okay. All right, so let's make our orders, blue. Let's make our orders table a little bigger. Okay, this is SQL. That's what I'm trying to give you a picture of. Okay, so these are our orders. Okay, now in our orders table, we have an ID field, the ID of the order, and then we have the user ID, which is the ID of the user who placed the order. And then let's say we have item. Okay, that is the item description. Okay, now like we said, each of our users have placed an order. So let's say John placed the first order, so it's ID 1 but user ID 2, and let's say he ordered a knife. Okay, and then Sue was the next order, ID 2, user ID 3, and she ordered, let's say she ordered lipstick. Okay, and then Sam, order number 3, user ID 1, let's say he ordered a fan. Okay, now the SQL language is a language that works with what we call relational database. Okay, relational databases are databases that establish relationship between each other, either the database or the table within the database. So for example, in these two tables, we can link these two tables using ID in the users table and user. So now let's link it. So let's say I'm looking for the user that ordered lipstick. So I will first come to the orders table. I will look for lipstick, and I will now look and see in the user ID field for that record. This is the record. I now see number 3. So what I will now do is from the orders table, I will go to the users table and I will query the record with ID 3, and that will give me my user. Okay, so that's what we call relational databases. So SQL is the language that is used with relational database. Okay. NoSQL is different. Okay, and I will do my best. If I make mistake, if anybody tells you I made mistake, just apologize for me. Okay, I'm going to try and describe NoSQL. I don't really use NoSQL databases, in my own work. I'm not very familiar with them, but as I continue gaining experience, I'm sure I will. But let me try to describe what is NoSQL. Okay, NoSQL is the language for non-relational databases. Okay, so they are databases, but they are not relational in the way that I just showed you with the tables and all of that. Okay, so let me try and think. The way this works is, let me use the user and the orders. Okay, now in a NoSQL, the user database will look something like this. We will have um it's almost like a hash table. Okay, so we will have, the record will open. Okay, and then we will have ID. Okay, and the ID will be 1. Okay, and then we will now have um the user. Okay, and then this user is now going to be its own hash. So under that user, we're now going to have name, and the user's name is John. Okay, and then we will close the bracket, and then we will now have so that is ID. Oh, sorry, I made a mistake. You can see this is not my strongest one. Okay, so we have um okay, so we will open the squiggly bracket, and then we have ID, which is 1, and then we have user, which is, it now has its own its own hash, and then we have name, and then we have John, and then we close that one. Okay, and then we close this one. Okay, that is, we close it. Okay, and then we have a comma, and then we open another hash, and then we say ID 2, and then user, and then we open, and then we say name is Sue, and then we close the first one, which is that, and then we close the outer one, which is and then at the end, because you see we have this open square bracket, so we have to close the square bracket. Okay, so the square bracket is linked like this. So this is a NoSQL database arrangement. Okay, now if we now come over to the order side, it's the same. Okay, so with orders, we'll first open, then we have our order ID, which is 1. Let's say it's Sue that made this order, and then under we will now have customer. Okay, and then we'll open that, then the customer ID, okay, is Sue's ID, which is 2, and then the customer name, okay, you can just have customer ID. Okay, you can have customer ID, and then we will close it. Okay, and then, oh, sorry, we don't want I don't think we need the comma there. And then we will, so this is ID, and then customer. Okay, yes, we need comma. And then we can now say item. Okay, and then item is hair. Okay, hair, comma, and then we will close that squiggly. So that's one order. Okay, and then we can have multiple. So with the NoSQL, there's a different way that you will traverse these records. Okay, I'm not going to go into that, but NoSQL language is for non-relational databases, and there's a way you will traverse. Traverse means you will go through it, locating the record you're looking for. Is a different way with non-relational database than relational database. Okay, all right. Woo. Okay, so I think I have finished that section. Okay, so I have finished, I think so, at least that page, key computer science concepts. I hope it has been helpful. I hope the explanations were helpful, and I hope I also helped to, reduce some of the anxiety maybe around, oh, how am I going to learn all of this? Okay. We're not asking you to become expert in it. At least that's what I think. I don't think the exam is asking you to become expert. It's just for you to have a high level understanding. At least if somebody mentioned it, you can say one or two things. Okay. So I hope this was helpful. Many of you have asked me to do lectures on other things that you're studying. So as I have time, I will do them, and it will either be live or it will be recorded like this, and I will put it on YouTube. All right. So thank you for watching. Happy studying. You can do it. Keep on keeping on, keep studying. Trust your ability to learn. Even if you don't know something, trust your ability, your God-given ability to learn and to grow. Okay. I'm rooting for you all. I'm praying for you all. Well done.